So, for the laws of logs, they're actually on the formula sheet, but I completely don't ever use them because you guys will understand the laws of logs and you won't need them. Separately, there's a product rule, which states that if you have two numbers multiplied together, you can actually separate them. Grab a marker. You can actually separate them by addition. So you can take two multiplications and separate them by addition. If you have division, you can take them and separate them by subtraction. So anything that is added on the top gets a plus sign in front. Anything that's subtracted gets a minus, which is a lovely formula, and it's great that it's given to you, but I promise you, you will never look at it because you will understand it without the formulas. Because the formulas are only good if you have two added or two subtracted. If we add more onto it, it throws you off. Now, in order to use these formulas, you have to have plus ones in front of your logs. So in order to use this formula, you have to have a plus one here, and plus one here, and a plus one here, plus one here, plus one here. Minus one's also okay, but it has to be ones. The other rule is your bases have to be the same. So in order to use this formula, you have to have plus or minus ones in front of the logs, and your bases have to be the same. So like base 7, 7, 7, 7, right? Or base 10, 10, 10, 10, or base 2, 2, 2, 2. The bases have to be the same. So we're going to evaluate these ones first. So if I have log base 2 of 16 plus log base 2 of 8, the moment I say 2 twice, I think, put my logs together. That's what I think. So whenever the bases are the same, it screams to me, I can go together, right? I can be one log. That's when the bases are the same. That should scream in your head. Just like when I gave you a word in perms and comms, and you immediately said, I need to start stacking letters. If I stack letters, I have to divide, right? Same thing should happen here. If you see common bases, you should think, put me together. Now, the only way you can put them together is if they have plus or minus ones in front. So this one has a plus 1 in front. This one has a plus 1 in front. Do you see that? So what we're going to do is we're going to write it as one log. So we're going to go log base 2. I don't know why it's so squiggly writing today, but it is. We're going to go log base 2 because they're both logs, correct? And if they have plus ones in front, they can go in the numerator. If they have minus ones in front, they can go in the denominator. Do I have any minus ones in front of any of these? No. So they're both just going to go beside the log. 16 and 8. And when you have more than one number, you will always multiply. So 16 times 8 is 128. So this is log base 2 of 128. And remember, you can type this into your calculator and get an answer. Or remember what your calculator is doing every single time? Is it saying 2 to what power is 128? Which I believe is 7. Yeah. So you can type it in and get 7, or you can say 2 to what power is 128. That's what your calculator is doing every single time you're doing a log base. Okay? Now, we're proving that we can go the other way. So we can take two additions, and put it together by multiplication, or we can separate them too. We could go log base 2 of 16 times 8. So we could separate them. Whenever there's a multiplication, we can go log base 2 of 16 plus log base 2 of 8. And you get 7. It still works out. So the rule, it works. If you multiply two numbers and do a log of that, or you add the two numbers and do a log of each, you get the same answer. So it's not just a formula that someone says, hey, it works. It actually does work. You can prove it with numbers. Okay? Same thing with division. Type this one into your calculator. Log base 3 of 27, or this is an addition one. Log base 3 of 27 is, you don't even have to type it in. 3 to what power is 27? 3. And then what's 3 to what power is 3? 1. So whenever you get a log base, that's the same as the number beside your answer is just 1. Log base 3 of 3 is 1. So this is going to get me 4. Now this is a much larger number. This would be log base 3 of 81. 3 to what power is 81? 4. So it's the same answer, right? So that's why when you take two multiplications and you separate them out by an addition of two logs, it actually gets you the same answer. So the formula does work. What about these ones? Let's try it out. Log base 2 of 16. 2 to what power is 16, guys? 4. Minus 2 to what power is 8? 3. So you're going to get 1. And if you can't do that, that's fine. You can go log base 2 of 16. It will give you 4. Log base 2 of 8. It'll give you 3, and then you subtract them, right? Not a big deal if you don't understand what I was just doing. Now, what's 16 divided by 8? 2. So this is actually log base 2 of 2. What happens when these are the same? Your answer is just 1. Okay, let's look at the other one. Log base 3 of 27 is what? 3 to what power is 27? 3. Minus log base 3 of 3?
1.
Is 1, because 3 to what power is 3 is 1. So this will give me a 2. And then 27 divided by 3 is 9. With the base 3 down here. And 3 to what power is 9? 2. So they match. Julia, can I get you to put your water bottle down? It's literally, oh, sorry. It's not your fault. It was just like, it was literally doing this to me. With the light, it was crazy. I don't know what. It's flashing. It was the sun's fault. I blame the sun. Okay, we're going to evaluate the following. Now, this is what I'm going to tell you. Please take this home with you. This is the thing you have to send. If you send this home into your brain and understand what you're doing and not distract others, you will find these really, really, really easy. So, what I'm trying to send home with you here is, you have to spot these first. Remember that you can put them together, but you can also take them apart, right? So we can take 2 multiplications apart by addition, or we can put them together, 2 additions together by multiplication. But how we have to spot these is this way. If I go log base 2 of 12 minus log base 2 of 3, if I hear 2 and 2, that screams probably that they're going to make you put them together. Okay? Log base 2 of blah minus log base 2 of blah, or log base 2 of blah plus log base 2 of blah, screams put them together. Okay? The other rule, not only is that you have to have the bases be the same, but you also have to have plus or minus 1s in front. And for the first little while here, we are going to have plus or minus 1s in front, but after that we're not. We're going to have to figure out what we have to do with that. So this one has a plus 1 in front, correct? And this one has a minus 1. Now those formulas above are lovely, but what you need to know is, if it has a plus 1 in front, it goes to the numerator of the fraction. If it has a minus 1 in front, it's going to go to the denominator of the fraction for the log when you put them together. Okay? So, because when we have 2, it's easy, but when we get more, what do we do? So here we're going to get log base 2, because we can put them together because 2 rules are satisfied. They're both the same base, they have plus or minus 1s in front. Correct? This one has a plus 1 in front, so where does the 12 go? To the numerator or the denominator? Numerator. This one has a minus 1 in front, so the 3 goes to the numerator or the denominator? Denominator. So we're going to get log base 2 of 4, which I can actually do in my head. I couldn't have done this one in my head. 2 to what is 12? I don't know. It's going to be a decimal. 2 to what power is 3? I don't know. 1 point something, right? That I can't do in my head, but could I do this one in my head now? 2 to what power is 4? 2. I just evaluated it. Algebraically. If I don't show any work, I'm just literally could be just typing in my calculator, right? If I want it showed algebraically, you're going to have to show it that way. Now B, this is where knowing the rules makes it easier. You have to have the same base. So B is log base 6 of 7, log base 6 of 8, log base 6 of 2. All the same base, right? Screams, put me together. That's what it does every time. Now, what do we have to have in front in order to put them together? 1s or positive 1s or negative 1s. This is a positive 1, negative 1. We agree? So we get log base 6. Where does this 7 go? Numerator or denominator? Numerator because it has a plus 1 in front. 8, numerator or denominator? Numerator because it has a plus 1 in front. What happens when I have more than one number? Multiply. And then the 2, numerator or denominator? Denominator because there's a minus 1 in front. And if I have more than one in the denominator, I'm going to multiply those as well. Okay, so just if I get more than one number in the numerator or denominator, I multiply them. So I'm going to get log base 6 of 56 divided by 2, or log base 6 of 50, or 28, which I can't do even easily in my head. But I know it's 1 point something. So sometimes they'll just ask you to write it as a single logarithm. So this is your answer. If they ask for single logarithm, you're done. And they'll make it so it doesn't work out nicely, so you can't just type it in your calculator and give a decimal. Okay? So that would be as a single logarithm, but this one actually told me to evaluate, so I have to keep going. What is the answer? 1 decimal?
8.5. So 8.6.
8.6?
Yeah.
Example 2. I want to write it as a single logarithm. What am I going to have to do first, though? Pray, and then past praying, what are we going to have to do? Dear God, please help us with this question. Then what?
But the plus ones?
I see a -1 with brackets. What do I have to do? Go to church is also a good option. So we have log base x of 10 plus log base x of 75 minus log base x of 2. Actually, I had that person...
This is less.
Oh, I know who it is. It's Mr. Batchet.
Is it Mr.
Okay, so we need to have plus ones and minus ones in front. Plus 1, minus 1, minus 1. And actually, what was brought to our attention is, if this is all being minus, could I just have put the 2 and the 3 in the denominator? Could I?
Yeah.
-1, -1. Yeah, I absolutely could have. Both of them would have had to make it into the denominator, so that was a good point. Okay? So, we have log base x, and then 10 has a plus 1 in front, so numerator. 75 has a plus 1 in front, so numerator. And then these, you could have just put both of them in the denominator because they would be negated, but you have to watch, because if this was actually a minus sign in here, it would have made it a plus and moved it to the numerator. So you do have to watch that. In this case, because they were both plus, they would move to the denominator. I always just distribute so I don't have to use as much brain matter. That's what I do. So -1 in front, 2 to the denominator, -1 in front, 3 to the denominator, and then I multiply, correct? What's 750 divided by 6? What do we get? Log base x of 125. Done. So what they can do is they can just throw an x in somewhere, and then you guys can't plug it in and give an answer and match them, right? So they'll throw a variable in most often.
That's me.
Yeah, they should say sorry.
There is no answer to this. There is no answer to
You
this.
can't just plug it with x in for the variable.
No, because what's your x?
Well, what happens if you just put...
Then it's whatever x is stored into your calculator. It's not helpful. All right.
So you can't just go long.
Yeah, you have to go get Humphrey and too. I'm gonna go around and ask all the
25.
teachers and just
And
like.
then you get -6.
It's a secret. I didn't tell.
He specifically said I gave him the gift early, so you have to.
But he doesn't know it was me.
No,
Yeah,
you
he
thought
does, he
that.
does.
No, you put it on their desk, and then you.
I didn't. You know how many times I have not known who my Secret Santa is and they won't tell me, and J.O. just comes up and says it's him, and he's lying? Like, he'll be like, it's me. And then one year I think it was him, but because he does it to me every year, I don't actually know if one year it was him or not.
Just ask Mr. Batcher.
So we're going to get log base 2. This has a +1, +1, -1.
Yes.
It has a +1 in front, so x goes to the numerator. Has a +1 in front, so 2x goes to the numerator. They will be multiplied. And then an x squared to the denominator. This is where it goes terribly. What is x times 2x?
2x squared.
2x squared over x squared. And then what happens from rationals?
Cancel at the x.
They cancel. So I get log base 2 of 2, which is actually
1.
the only answer not handed to me, which was 1. C, A, B.
I said B.
Seriously.
Everywhere.
Next page.
I could circle the blank space.
All right. So this one here, we have if log A is 6 and log B is 3 and log C is 2, determine the values for these. So if I can get log A, I can put in 6. If I can get log B by itself, I can put in a 3. That's what that means. Okay? Currently, I have log AB, which is none of these options. But all we've done so far is taken logs taken a separate logs and made them be single logs, correct? But what we can also do is we can take a single log and we can make it be separate logs by addition and subtraction, correct? So if I have a and b like this, I will always rewrite it as a times b. So it reminds me that they are multiplied, and I can separate them with what?
Addition.
Addition. If they're in the numerator, they get a plus 1 in front. If they're in the denominator, they get a minus 1 in front. So this is going to be plus 1 log a, which you don't have to write the plus 1, but I'm proving a point. And then, because it's in the numerator still, I can go plus 1 log b. What is log a? 6. Plus, what's log b? Trays. And our answer is 9. 9. Niner.
Wait, but I thought what? Log bases have to be the same.
They're all base 10.
Oh.
They're all base 10 if there's no base. Okay, b, what can I do? Shh. What can I do with b? Log a minus log b. Please don't go log a divided by log b. Don't go try and distribute. That's where things go bad, and they will have that answer there. So when I have a over b, the a is in the numerator, so I'm going to get a plus 1 log b, or log a, which I don't actually have to write, but I'm proving a point. Plus 1 log a. B is in the denominator, so I get minus 1 log b. So I'm going to get 6 minus 3, which is 3. For c, what am I going to get? I'm going to get
log a plus 1 log b plus c.
Plus 1 log a plus 1 log b plus 1 log c. So I'm going to get 6 plus 3 plus 2, which is 11. What about d? Yeah. Log a minus log b, because it's in the denominator, minus log c, because it's in the denominator.
Do we have to put brackets around log bc?
This part?
Yeah, or no, like around, like
No.
the log, okay.
No. Just like this.
Because I noticed it was in the other questions, so I didn't know.
No. You're going to do them separate. The other question makes it more confusing that way. So you're going to get 6 minus 3 minus 2, which is actually 1. We're going to go down to these ones. So, what am I going to get for this one? Log base 4. Log base 4. Ah, they scream, put me together and get off my phones. That's what they scream. It's crazy. And then you get a plus 1 and a plus 1 in front. So when they both have plus 1s, where do the numbers end up? Numerator. So do I even have a denominator? No. So I get log base 4 of 8 times 2, which is log base 4 of 16. And that's as a single logarithm. So if they ask for single logarithm, I'd stop there. But it says single logarithm and then evaluate. 4 to what power is 16? 2. You guys going to try B and E? Breaking and entering. So this one we get plus 1 in front, minus 1 in front, log base 5, log base 5. With those rules, I can separate. I can put them together. So I go log base 5. 100 goes in the numerator, and 4 goes in the denominator because there's a negative 1 in front. So I get log base 5 of 25, which is what? 2, because 5 to what power is 25? 2. It's a nice one. Okay. We look at E. These are all base 10s. I'm going to tell you right now, if a log doesn't have a base, I immediately put the base 10, because after drawing 1 or 2 base 10s in a row, it screams, put me together. And if it doesn't, you got problems, because it should scream, put me together, after writing the third, log, base 10.
If you
Okay.
just press the log button on your calculator, does it automatically assume it's just base 10?
Yes.
Okay.
So, Here we're going to get log base 10, which you don't have to write the base 10, but I'm doing it to prove a point. 25 goes in the numerator, and then a half goes in the denominator, and 5 goes in the denominator. Now you can just type that into your calculator, right? You can go 25 divided by bracket 0.5 times 5. And it miraculously tells you it is what? You have to go 25 divided by 0.5 times 5, and it's 10. The answer is 10. 2.5 is the denominator.
Sure.
25 divided by 2.5 is 10.
Yes, I know.
Yeah, I just want 10. I didn't want the, I know what you're doing. You're going with this, which is totally good. 25 divided by 2.5, which is equal to log base 10 of 10. What's the answer to log base 10 of 10? 1.
What? I don't.
1 over 2 times 5 is 2.5. No. 1/2 times 5 is 2.5. 25 divided by 2.5 is 10. You have to put your denominator in brackets. Okay. All right. So there's a rule called the power rule. Why would the power rule come into effect? There's a time right down there, and I could even fill you in. It is 11:09 and it ends at 11:22. Put your phone away. All right. So why is your power rule so important? Because what do I have to have in front in order to put them together? Ones, correct? If I have numbers in front, I need to get them to go away, go bye-bye, so that I can put them together. So there is a rule that if you have a number in front, you can actually raise it to the exponent if and only if the word log exists. So I can take that n and I can drop it in front. So an example would be, if I have this 2 in front, I want it to be a 1, correct? So I can just take the 2 and I can put it up here. So I can get log base 3 of x squared. And then I would be able to deal with it and put it together, because it would have a plus 1 in front now, correct? What about this half? I can bring it up, and I can go log base x of 1/2. This I can bring the 4 up. I could go log base 6 of 2 to the 4. Now the -1 I could bring up. I can bring it up. But I could also just put this together if it had -1 in front, correct? But they could ask me to put it up here. If I wanted to, it would be log base a of 2 to the -1. Now for putting them together, I wouldn't actually move that negative sign. I would leave it in front and just drop the number to the denominator instead. So let's look at some examples here. Example 5 says determine the value of 3 log 2p minus 3 log 2q. So they want us to give them the value of 3 log 2p minus 3 log 2q. Only information they gave me is if you can get something in the form p divided by q, you can insert an 8. That's what it tells me. So can I put those together currently? They're both base 2, which tells me, screams to me, I have to put them together, correct? But what's my problem? The 3 is in front. So I can move the 3 up by using power rule. So I can put the 3 here. I can put the 3 here. So I get log base 2 of p cubed minus log base 2 of q cubed. Do you see how I didn't take the minus sign with me though? I just left it there. Because if it's a minus sign, the q cubed just drops to the denominator, correct? Now they have a plus 1 in front and a minus 1 in front, so I can put them together. I can go log base 2. What goes in the numerator? P cubed. What goes in the denominator? Q cubed. Now it says up here that I need to have just p divided by q, and then I can fill in an 8. Yeah.
Can you just take up the cube root?
You can take the cube and put it outside the bracket. You can do that. So because they're both cubed, I can actually take the 3 and drop it out. We're always so used to putting it in, but we can actually take it out because they both have it. So we can go log base 2 of P over Q, all cubed. And then what did I tell you about the P divided by Q? What is just that? 8. So instead of having P divided by Q, I could actually just put an 8 in here. So this would be log base 2 of 8 cubed, which is something.
27.
27. And then that's the numeric response answer, right? So it turns something that looks like it can't be a numeric response answer to a numeric response answer. You guys going to try example 6A? It's an easier one than the one I just did. So that one I could just put together, correct? Because it had plus or minus ones in front. The last one I actually had to use the exponent law. Or the power rule, I mean. Okay, we're going to flip over. All the times you're on your phone.
I wasn't. I went on once.
Once this class for half the class. Okay. So, I want you to do B and C. We're going to be going through these on Monday. Then I want you to skip over 7. We're going to go to do 8 first, and then I'm going to actually have you do the rest, but we're going to go through this one first. What's my problem with 8? Numbers in front, because the other problem is not there. Base A, base A. That's good. Check. Our problem is the numbers in front. We have to bring them up. So we're going to get log base A 16 to the half minus log base A of 8 to the third. Now 16 to the half is just actually the square root of 16. But if you don't know that, type 16 to the half into your calculator. Go ahead. 16 to the power of a half. And we get 4, which is much nicer than 16 to the power of a half. Minus log base A, 8 to the power of a third is actually a cube root of 8, but if you don't know that, you can go 8 to the power of 1/3, which is just 2. Now it's nice for me to put it together, correct? So now I have log base A, what goes in the numerator? 4. What goes in the denominator? And what is 4 divided by 2? So my answer on my test would be log base A of 2. B has no basis. So the moment that it doesn't have a log, doesn't have a base, I go start putting 10s. And then hopefully it reminds me. So base 10, log base 10, log base... they're all the same. What's my problem currently, though? Pardon? That 5 in front. The other ones are good, right? It's just the 5 that's causing me a problem. So I'm going to get log base 10 of A minus log base 10 of e to the 5 minus log base 10 of a squared. And then I'm going to get log base 10. A goes in the top, e to the 5 goes in the bottom, and a squared goes in the denominator. So this one's a to the 1, that one's a squared. What can I do? We can cancel an a out of both, right? When the whole numerator cancels, is it just gone? It's a 1. So we get log base 10 of 1 over, and I like going alphabetical, so I'm going to go a e to the 5. But if you go e a to the 5, you're still correct. So on Monday, we will be going through B and C, and we will be going through these. You have to do these as well.
All the returns?
All the your turns.
Get that done over the weekend?
You have 4 minutes. If you work quickly, I bet you'd have most of these done. These are really fast. They're all with variables. You can't even like figure out math in them.